Hello, everyone. I think we should start the webcast now. See, we'll wait for some more people to join in. If you would like, you can click or hover over the lower part of your screen. You should see some menus pop up. And if you click on the one that says chat, you can enter in where you're calling from today. I'm Jim Madsen. I'm the Executive Director of the Wisconsin IceCube Particle Astrophysics Center at UW-Madison. And joining us today will be John Harden and Yuya Makino from the South Pole, and Jargi the Science Girl. So we're very glad to have you all here. So we've got Cassie from Arkansas, all right? Okay, and then attendees, okay. Oops. Sure. Hi, John, can you hear us?
Hey, I can. Can you hear us?
Yep, loud and clear. I just have to, I unmuted Jessica by mistake. So, okay, but she's muted again, thanks. All right, and then we've got from Alaska, Susan, and then Judy from New Hampshire, and Katie from North Carolina, and Donna from Illinois. So welcome to you all. Okay, and let's see, let's give one more minute. And then we'll get started. We're very excited to have Jargi the Science Girl with us. She can tell you about some of her adventures, and she might surprise you where she's been. Another couple from two people from Alaska. Let's see, from New Hampshire, Elaine, who we know from Los Angeles. Hi, Elaine. From Massachusetts, Elena, and then Lori from Washington State. That's great. Well, we're so happy you could join us, and so far so good. It looks like we've got Jocelyn here, and Jocelyn, aka Jargi the Science Girl, and John. So I think we'll go ahead and get started. I'm going to turn it over to Jargi.
Hello, scientists. Hope you can see me. How is everyone doing today? Oh, I'm so excited. Welcome to our virtual adventure. My name is Jargi the Science Girl, and this is my lab assistant, Benjamin. Normally, we travel all across the United States, inviting scientists like you to visit our laboratory. But in December, we got a very special invitation to join scientists that live and work at the South Pole. In other words, we traveled from sunny Los Angeles all the way to the bottom of the world. And today, we're going to bring you along and share some interesting things that we learned down below. So, are you ready to go, Benjamin? Oh, right. Whoops. Since we're going to the South Pole, first we have to make sure we have all of our safety equipment because it is unlike any place on the planet. And as you might have guessed, it's very, very cold. So let's see. There's step number 1, our extreme cold weather gear. Just like my red parka. This is the coziest thing that you'll ever wear. Here we go. Much better. Check. Step number 2 is hydration. Not only is Antarctica really cold, but it's also very dry, like a desert. So grab some water. We're going to need it. Check. And step number 3, this one's my favorite. An infinite amount of curiosity. Take a second. Find yours. Do you have it? Do you have it? Great. Then I think we're all ready to go. So we're going to hop on our very first plane and head down south. Our first stop is going to be along the coast of Antarctica. Here you can see it marked by a yellow star. There's a large US research station here that's called McMurdo. We're here. We made it to Antarctica. Oh, it's very chilly. When I first arrived here in December, it was summertime and the average temperature was 20 degrees Fahrenheit, which is already pretty cold for us from California. McMurdo is a research station along the coast, and behind the sign here, you can see frozen water that's called the Ross Ice Shelf. And it's so frozen that you can go skiing on it, like I did, or even ride snowmobiles, well, in very safe, designated areas. Since it's a research station, a lot of scientists visit during the summer to work on their science projects. When I was here, there must have been almost 1,000 people, and not just scientists, but also artists, chefs, mechanics, all these people that help the station run nice and smoothly. It's kind of like a little Antarctic town. Now, besides all the humans, there's also a lot of wildlife on the coast of Antarctica. You get to see things like birds, seals, whales, and penguins. Well, other kinds of penguins. My favorite thing to do at McMurdo was to stare off into the Ross Ice Shelf and try to count all the seals. They would come up through the ice through holes or cracks, and then they would just lay there for hours and hours and hours. And anyway, after a few days at McMurdo, we can hop on our second plane and head to the South Pole. The South Pole is towards the center of Antarctica. Here you can see it marked with the pink star. We made it! Yes, we're here. So behind me is the Amundsen Scott South Pole Station. It's named after the first 2 people to get to the South Pole. I wonder what number we are. Not only did we travel inland to get to the South Pole, we also traveled upward. The South Pole Station is located on top of a glacier that's 9,301 feet in elevation. In other words, the air here is very thin and a lot colder than the coast. In December, the average temperature with the wind was negative 30 degrees Fahrenheit, way below zero. Luckily, I had my gear with me, but this is cold. Luckily, there is a lot that you can do indoors in the station, and there are even individual rooms for up to 150 people. Pretty cozy for being at the bottom of the world. Now, outside of the station, things look a lot different than they did at McMurdo because there is no wildlife. Yep, there's no birds, there's no seals, and there's no penguins. Well, except when Benjamin visited. He was very special, and he felt it too. Anyway, although there aren't any animals here, there is still a lot of science that happens all day and, well, all night. Because during the summer, the sun doesn't set. That's right, 24 hours of sunlight. That's something really unusual to get used to. And I got to work on really incredible science with the IceCube laboratory. The IceCube laboratory is actually just a short walk away from the distance. Let's check it out. Well, here we go. The famous IceCube laboratory, or ICL for short. The ICL is a very interesting looking building, and it's on top of an enormous physics project that's buried in the ice. Observe. Under the ice, there are cables up to 1.5 miles deep that are holding 5,000 detectors, over 5,000 detectors. And these detectors help us find neutrinos. Neutrinos are tiny particles that we can't see, but they can come from outer space. Every time a high energy event happens out in the universe, like when a star explodes, neutrinos are born and zoom through the universe. Normally, we don't really notice that they're there. In fact, right now, there are millions, there are trillions of neutrinos that are passing through you, through me, and through Benjamin, but we don't notice them. Sometimes, however, these neutrinos will bump into the ice at the South Pole and give off a burst of light. Since the ice buried deep down is transparent or clear, our detectors can see the light and tell us where these neutrinos are coming from and what in the universe might be causing them. It's like we're studying the universe from the bottom of the world. So cool. So cool. We're back. Woo, nice and warm again. If you want some more details about when we were there in December, you can follow our blog. We'll share the link with you today. But a lot has changed since we went to the South Pole, because right now it's winter time there, which means the sun finally set. And life changes a lot in the dark. So there are 2 winter overs for the IceCube laboratory that are stationed there right now, and they're going to tell us what's changed since December. Are you there? Can you hear me?
Yeah, we can. Hey.
Awesome.
Hey,
And before you get started, Jocelyn, you need to go over and let me be the host
Oh, okay.
of the participants. Jargi, if you could do that.
How do I do that?
You
Let's
go over where it says more. If you hover over IceCube Education,
Yes.
it says more.
IceCube. More.
Okay. Will it let you?
Let's
I can be
see.
the host. Okay.
Over IceCube.
Okay. And if you have any questions, you can either put them in the chat box or the Q&A box. All right. And now I'm going to share my screen and then have John and Yuya introduce themselves.
Okay. Are you the host now?
I'm the host. Thank you so much,
Beautiful.
Jardy. Is everyone seeing the sunset right now?
We can.
Great. I think that means everyone can. So go ahead, John and Yuya, if you want to introduce yourselves.
Sure, yeah. Hi, I'm John Harden. I'm down here as one of the IceCube winter rovers, and this is.
Yeah, hi.
And yeah, we're down here and we keep the detector lights on. Should we jump into the pictures?
Yeah.
Okay, so as Jargy mentioned, there's only one day and one night down here. So on March 20th or 21st or so, the sun sets and it doesn't rise again until September. So it's been dark here and the sun's been slowly setting since then. We actually still have a little bit of light outside, but this is a little bit what it looks like as it's setting. It just spirals down in the sky. You can see it behind the ICL here. Most of these pictures are going to be by Yuya. Yuya's an excellent photographer. So next slide, please. Yes. So this top picture, you can see the sun is just right on the horizon, just as it slowly comes down. And then here is the ICL at night. That in the background there isn't the sun, that's the moon. It's dark enough out here otherwise that you can actually navigate by moonlight. Jargy's a much faster walker than we are. It's about 2/3 of a mile away, so we do have to work a little bit to walk out to the ICL. But yeah, you also see the red lights that we put on all the buildings. We can't have white lights out here we risk damaging some experiments that are looking at the sky. So we do everything that's red. So yeah, so we can go on to the next slide. Yeah, so auroras. So last week we saw our first aurora. Neither Yuya nor I had ever seen one before. We were actually out shoveling snow at the ICL, and yes, we do shovel snow at the South Pole. And it just popped up in the sky, and we were very, very excited. And since then, they've come out again and again, and every day we're getting a few more stars in the sky as it gets a little bit darker. The sunset is very slow here. Think about, a full sunset stretched out over a day. But yeah, these are some pictures we've taken on our Instagram. You can also see the Milky Way in the bottom left picture. It's dark enough here that it really pops out in the sky. It's really cool. I had never seen some of the constellations in the Southern Hemisphere, and I was very excited to see them, and it's just great going out there every day. So yeah, the biggest change here from the pictures you saw with Jargy is that it's now dark. It's gotten a lot darker, but we're hunkered down and we're settling in. So yeah, next slide, please. Very good. How much do we want to go through IceCube at the South Pole and all of that? Because I'd love to. Are you there, Jim?
Yeah, let's go to questions, okay, John? And Yuya?
Okay, sounds good.
I'm going to stop sharing and jump back, and there's Jargy is back again with Benjamin. That's fantastic. Okay. All right. And so let's see if we have any questions. Let's go back up here. And the first question is from Veronica, and she wants to know what flag is on the top of the IceCube laboratory.
Oh yeah, on top of the IceCube.
John, do you know?
Yeah, so we don't, hi Veronica, we don't have a flag up there anymore. That was a flag of one of the universities who was coming down here doing science.
Uh,
They were taking a picture of themselves and showing support for their university.
Okay. And Jargi, when you were here, was there a flag up?
I don't remember if there is a flag on ICL. There are flags in front of the South Pole Station. They're arranged in a half circle. And those are the flags from the first 13 countries who signed the Antarctic Treaty, which is basically like, it's an agreement to protect and conserve Antarctica and to respect the continent, and which is really great to remember, especially on Earth Day.
All right. Okay, and then the next question I'm going to add a little bit to. It basically says why do we get only one day and one night? Why does the sun do that rather than rising and setting like it does in everywhere else?
So, oh, go ahead, Jargi. You got
Oh,
it.
I was just gonna bring my globe. I can kind of model it as you, if you want to explain.
Nice. And go ahead, John, you can talk and she'll, and Jargi will
Oh,
model.
okay. So the Earth, as it goes around the sun, you may know is a little bit tilted relative to how it goes around. And when it rotates, normally that's what makes the sun rise and set. But at the South Pole, we're not moving as we rotate because we're right on the axis of how the Earth is rotating. So the only thing that's making the sun go up and down is how we're tilted relative to the sun. So normally in the north, the days will get longer and shorter in the winter and summer. As you get farther north, they get more longer and more shorter in the winter and summer. And where this, that actually just maximizes when you get all the way to the pole, where you get the longest possible day and the longest possible night, where you just have one a year. Is what's going on there.
All right. Nice. So they want to know what time is it, and maybe you should tell them what day also.
So that's a good question. So down here at the South Pole, we run on New Zealand time, which is about, I like to think of it as it's 7 hours behind Central Time tomorrow, or you can say it's 17 hours ahead of Central Time. So it's the 23rd down here, and it should be the 22nd up there, and it's just about 10:23 in the morning, AM.
Okay, great. So Jargi, did you try to call anyone when you were at the South Pole?
I did. I tried. I sent a lot of emails, which would take some time to get a response. But the few times that I got to call some of my friends back at the lab here, the time difference was very interesting. Sometimes I would be eating breakfast and they would just have finished, I don't know, almost dinner time for them. So the time difference is something to get used to.
Yeah. Okay, this next one is from Karen, and she says, your research center is on a glacier. Wouldn't the glacier move?
Oh, that is an excellent question.
Yeah.
So the top level of the ice here does move. It moves about 30 feet per year, which is, pretty slow, but pretty significant if you're stretching some table and you want to run for 10 years. IceCube was prepared for this. They actually have a lot of slack in their cables, so we're ready to stretch as the glacier moves under us. The other fun aspect of this is the geographic South Pole we go and it gets resurveyed and moved every year on New Year's Day, and it's a really fun ceremony.
Yeah, okay, very, very cool. So the next question comes and says, can we see John on screen? And I don't know if we have enough bandwidth to do that.
I don't know either. If we did, it'd have to be just briefly. The bandwidth down here is quite restricted.
You want to just flash your, see if you can show us quickly, and then you can go back to.
Yeah, right now I think I'm down as a meeting participant. I don't know if I can get any sort of.
I can change it. Let me try it. Yeah.
Okay.
I'm going to promote you to a panelist, then you should be able to do it. Let's see. Let's see. I'm not sure, it's not showing up. Oh, there you are. Okay. Now you're officially a panelist. Can you try?
There we are.
There you
Hey.
are. Yeah, awesome.
Hi.
Hi.
You are from the South Pole. Fantastic. You got to slide over a little, you. There.
Hey.
Very good.
We're sitting in the conference room down here. There's a bunch of souvenirs and books and stuff behind us.
Awesome.
So
All right.
cool.
And maybe you could just say, where are you from, John? And Yuya, where are you from?
I'm from St. Louis, Missouri, originally.
I'm from Japan.
Nice. Okay. Okay. Very good. And so we have Clark wants to know, how cold is it right now at the South Pole? And Clark's mom wants to know, what kind of instruments are you keeping running?
Right now, it is very cold. Let's see. Yesterday night, I haven't checked the weather this morning. It was -70 without the wind chill and -100 with the wind chill.
Yeah.
So very, very, very cold. And honestly, the wind got a lot better yesterday. Right now, it is -81 without the wind chill and -120 with the wind chill.
Oh my goodness. Yeah. And then
It's very, very cold outside.
they're interested, what kind of instruments are you keeping running?
So we keep, you saw Jargi made a picture of the instruments in the ice. Well, each of those little spheres were like a pixel on your camera. And they detect light that we get when the neutrino interacts with the ice. So what we do is we keep the computers running that analyze all the data that comes from those little pixels. And we also will sometimes try and fix the pixels from a distance. We have to talk to the pixels through a mile of ice when they go down. They have little computers on them that we fix as well.
Cool. Okay. And this next one says, what kind of experiments are done with neutrinos?
Mhm.
That's a very good question.
Yeah.
So the neutrinos we look at down here are what's called astrophysical neutrinos. And we're using those to understand what goes on in space and understand what goes on at the center of galaxies and when stars and neutron stars interact with each other. There are actually all kinds of other neutrino experiments that go on Earth, but I won't get too far into those. But they're fun. They happen at accelerators. The Fermilab in Illinois is big into doing some accelerator experiments with neutrinos. They're much lower energy than the neutrinos we look at, though.
Okay, great. And then Jargi, you might know the answer to this one. Are there any plants growing at the South Pole?
Oh, There are, but they're not outside like you would expect. So inside of the station, there's a greenhouse with very specific conditions to combat the cold and the dryness, and it allows plants to grow. So it controls the humidity. When I was there, unfortunately, they were just setting it up, so I didn't get to see any of the plants actually growing, but I've been keeping up with John and Yuya, and I've seen pictures. It seems like they have some stuff starting to grow and can have fresh vegetables throughout the season. So that's pretty awesome.
Have John and Yuya, have you harvested anything yet from the greenhouse?
Oh yes, we've harvested quite a bit, actually. We have cucumbers growing in there. We have good tomato plants, lots of cherry tomatoes coming through. There's kale, all kinds of greens. We just yesterday we went through and we cleaned out a lot of it, and we're replanting. The plants kind of have a life cycle that they go through in the greenhouse.
Cool. Yeah, very cool. All right, and Natalie wants to know what's the coldest temperature and the warmest or the warmest temperature ever, and that's actually from Finnegan, age 9, from Montana, I think it was.
So let's see. So if I recall, the warmest temperature ever recorded down here was 9 degrees above 0 Fahrenheit. And I believe the coldest temperature was something like minus 113. And that's without the wind chill. The wind chill is when the wind is blowing, it feels colder on you. So the temperature on a thermometer will just record the temperature of the air. But when you walk outside, if the wind is blowing, it's going to feel a lot colder. So those two temperatures are without the wind blowing.
Great. All right, here's one for Jargi. How many penguins are there at the South Pole?
There are no penguins. Well, when Benjamin was there, there was one. There's a lot of stuffed penguins, penguin decorations. Actually took a lot of photos of penguins all around the station, but there are no live penguins at the South Pole. There are some live penguins on the coast in McMurdo. And when I left, it was still just a little too cold for them. But a couple weeks after, I started to see a ton of pictures. I think, John, you shared some, right? You got to see a lot of penguins along the coast.
Yeah.
No, I was lucky enough to be at McMurdo when there were a ton of Adelie penguins out, and we saw a lot of them there.
Yeah, it's not usual even for people to see them near McMurdo. It's the conditions have to be just right, and so many of my colleagues have gone, you know, maybe even 10 times and never seen a penguin. So yeah. Okay, and the next question is from Silas, and he wants to know how do the neutrinos go through you?
So that's also a very good question, Silas. The neutrinos only interact with what scientists call the weak force. And scientists call it this because it's very weak. And in order for something to interact with you, in order for it to not go through you, the force has to be strong enough for it to be likely to happen. And so because neutrinos just are this little, it's like a little puff of nothing, they almost never interact with you because you aren't very much matter to them.
Yeah. That's great. So I just want you, John and Yuya, to know that you're inspiring. We got a message that says, our sons want to be winter overs one day, right? So,
Hey, I empathize, trust me.
yeah, okay. And so let me go over here and just ask this question from Ben. He wants to know, how deep is the snow and ice? Oh, sorry, that's from Liam, age 9.
Oh, hey, Liam. That's a good question. The snow, most everything down here is not, strictly speaking, snow. It's mostly ice crystals. As Jurgi said, the elevation here is 9,301 feet. So all of that elevation pretty much is ice. And then the very bottom bit, there's a little bit of rock at the bottom, but all 9,300 of those feet, that's ice. And the ice goes very, very deep. We like to say it's almost 2 miles.
Cool. And so I think maybe Jargi, you got a chance to do something associated with this. There's a question from Michelle. It says, are there any ice core samples taken near where you are?
I didn't get to see any ice core samples when I went.
Did you go out where the spice core was?
Oh, yes.
Yeah.
So it was related to that. One of the projects that we did that I worked most closely with is called Spice Core. And that's a couple miles from the station. So I actually got to ride a snowmobile out to the field station, and you look around you and there's like, you can see for miles, just ice. And at the field station, they have an opening that goes miles deep into the ice. And so in this opening, they lower down different instruments and they take different measurements of the ice so that we can understand the ice. And as IceCube keeps upgrading, we can make instruments that are better suited to how the ice reacts to light, or how light works in the ice, and we can make our project, or the IceCube project, even better. So the Spice Core was really cool because we're literally putting instruments down into the ice, collecting information, then using that information to make the project even better.
Yeah, so I was at the South Pole 3 years ago when they were drilling that hole. And so I got to see them take the cores out. So I saw ice from 1,700 meters below the surface.
Whoa.
Okay, the next one.
Did you have a soda with the ice in it?
I didn't. No, that ice was being used to study. So they were gonna actually study the ice. So we didn't get to actually partake. I think there was some ice from closer to the surface that people got to sample. Okay, the next one is from Kim, and wants to know, can you collect neutrinos in other places around the world?
Yes, you can actually, Kim. There's a few other experiments. There's an experiment that's trying to do a similar thing to IceCube in the Mediterranean Sea called Antares, like the star. But there are also experiments that, there's an experiment in Canada that studies neutrinos from the sun. And there's experiments in Japan. You may have heard of Super Kamiokande. It's an experiment that runs in a mine in Japan that looks and tries to collect neutrinos from the sun. It's a really big tank of water, not quite as big as IceCube, but a very big tank of water that sits in a mine. My last job was actually on a related experiment called Canline Zen, and I got to tour Super Kamiokande.
How about you?
Super K is actually real near where Yuya grew up, right?
Yeah. Have you been to that Super K, Yuya?
Actually, no.
No.
I didn't have opportunity to go there.
Okay. All right. Our next question. This is very important. How do you get food when you're at the South Pole?
Yes, I agree. That's very important. So nothing grows here except in the greenhouse. And we get a lot of food from the greenhouse, but it's not enough to support everyone here. I think there are 42 people here for the winter, and there are close to 150 or so in the summer. So all of the food comes in on airplane. Most all of it. There's some that gets dragged here by a tractor, but almost all the food comes in on airplane. And we bring in enough food to last us as long as we could possibly need. There's all kinds of ice cream. We have the world's biggest freezer down here, so there's no worry of things going bad anytime soon. We can keep it stored for a while.
Maybe you could say, but kind of a couple follow-up questions from me. So what about fresh food? And then about, I think sometimes people ask what you miss, or, you know.
So fresh food is a very good question. They're called freshies down here, and they're worth their weight in gold. Because if it's something you can't freeze, then eventually in the winter you run out of it. It's kind of a shame, but you survive on the greenhouse freshies, and you get as much as you can at the beginning of the winter. So we had a lot of apples and oranges, and we bring in cream, and the eggs last for several months. The fresh eggs, that is. And you do as much as you can, and then by September, October, you're ready for the plane to come in with new freshies. As for what you miss most, for me, it's things like branded food. So honestly, it's a little embarrassing, but you know, fast food. There's a really great pizza place in Madison, Ian's Pizza, where there was taqueria in Boston that I really miss. I was in Boston before I went to Madison, and it's taqueria. Just stuff like that, kind of food that's prepared in a way that you've gotten used to and you really like.
How about you, Yuya? Anything you miss?
No, I'm just happy with here.
Yeah. Yuya's a big fan of steak, and there's quite a bit of steak served here.
Yeah.
Right?
Yeah.
How about Jargi? Was there any food you really liked when you were here at the South Pole?
Oh man, I was really impressed by all of the meals that we had, because they were really great at using similar ingredients to make different meals. So we had like pastas, and we did have steak. Those nights were delicious, steak and lobster nights. And then Fridays we had Mexican food. So it was really surprisingly delicious. You wouldn't expect that, being in the middle of nowhere, to have such great food. But I do remember towards the end of my visit, there were oranges. Oranges showed up, and it was the most delicious orange I've ever had, because I hadn't had any fruit for a couple weeks. I'll never forget that orange. It was so good.
Yeah, it's
And the food continues to be great in the winter. The galley staff here is just amazing with what they can do. We have a baker down here and she's dangerous for weight gain, but otherwise she's excellent.
yeah. Cool. All right, and so the Taylor girls want to know: do you ever get hurt from the glaciers or ice or the temperature or the snow?
Do we ever get hurt?
Yeah. So yeah.
Yes. With the goal down here, and the goal with the extreme cold weather gear, is that you do not get hurt from the cold weather. But one of the most common types of injuries down here is what's called a cold injury. And it goes from frost nip to frostbite. And it's something we have to be very careful about, because especially when it's this cold in the winter, it can happen fairly quickly if you're not watching your hands and your face. The Big Red is actually incredibly warm, and we have some very warm boots and some very warm pants, actually. So the only parts of us that really are dangerously exposed to the cold would be our face and our hands. So when we go out in this sort of temperature, we're completely covering our face. It looks a little bit like a ski mask. It's called a balaclava. Put on a hat, we put on goggles, we make sure there's no gaps, because if there are a little bit of gaps, then wind can get in there and it can give you a little bit of burn. The other big danger is when we're out taking pictures, honestly. Our hands are touching the metal, and we have the thinner gloves, so we have a little bit of dexterity. So I was taking pictures yesterday, and I was out for 5 minutes, in for 10, to keep my hands from getting too cold. The one danger here that people don't talk about because it's not as obvious is actually the altitude. When you first get down here, it's usually such a shock of change in altitude that your body isn't ready for it. So one of the biggest things that sends people to medical are young, healthy people who 2 days after they get off the plane, go into the gym and get on the treadmill at their normal speed. And it just knocks them over because if your body isn't used to the oxygen content, it's really humbling. Let me put it that way. I did it after a week or two at a slow speed, and I was winded pretty quickly. I've been training to get back up to my normal pace.
How about you, Jargi? Did you have any trouble with the altitude?
I did. I think on my second day or third day, I tried to walk from the station to the ICL, and it seems pretty close. It's less than a mile, but boy, once you're wearing all your gear, the air is a lot thinner, so there's less oxygen in the air, and you really feel every step. So they recommend to take, a few days and just not do anything. And I would say those days of doing nothing and just staying in the station and exploring really helped. I have a boot here. These are bunny boots that I wore at the South Pole. So on top of this big red parka, we have a lot of layers. And then we have boots that are like this or very similar. And the bottom of the shoe is actually here. So it's very, very thick to help insulate your foot. These are pretty heavy. So you're carrying about 10 plus pounds of gear, and the air is thin. So it takes some getting used to.
And what was the coldest temperature you had been in before you went to the South Pole?
That I had been.
Yeah.
Well, I'm from California. We're here in the LA area, and the coldest was I visited Madison before. So here in LA, the coldest temperature was probably 60 degrees, and I was cold, bundled up. Then I visited Madison, and it was maybe, how cold is it? 40 degrees. And I was really cold. And then I got to the South Pole, and it was -30, -35. So that was a shock, but all the gear really helps. If you layer up, you actually feel pretty comfortable outside because the sun is shining, and it's not too bad. Not too bad.
Yeah, great. Okay, John and Yuya, they want, Cassie would like to know how many total staff are at the South Pole Station during winter.
So that is 42. So during the summer, we're up to 150. We get down to less than a third of that during the winter. There are 42 of us between science and galley and UT, people who keep the station running, and the power plant, and people who keep the machines running and everything.
Okay, great. All right, here's a very technical science question from Karen. She wants to know, what is the weak force and why does it matter to neutrinos?
Okay, I'll see what I can, if I can say this in a quick way. So when physicists think about the world, they think about 4 kinds of forces. They think about the gravity, which you drop something, you have gravity. They think about electricity and magnetism, which we talk about as one force. This is the force that'll stick a magnet to a refrigerator. It's also the force that explains why you get light out of a light bulb. And there are 2 other kinds of forces that took a lot longer to kind of identify because they're a little bit rarer, they're a little bit weirder. There's the strong force and there's the weak force. The strong force, as you might imagine, is a little bit stronger than the weak force. The strong force is what holds nuclei together. So it's what helps nuclear power plants run. The weak force is a different force that explains radioactivity, but that's not all it does. All particles will actually interact with the weak force. It's just that most of the time you don't notice it because they're interacting with other forces as well. So the thing about neutrinos is they don't interact with anything except the weak force. And because they only interact with this very tiny force that's kind of a rounding error on all the other forces, that's why they only interact very rarely, is because it's only this very weak force that they're willing to talk to.
Okay. All right, yeah, that's not an easy question. So nice explanation. So I'm going to kind of combine a couple of questions here that have to do with the COVID virus and quarantining. Maybe you could say, is the COVID virus a concern for you? And then how many people are coming in and out at the South Pole right now?
So those are definitely very related questions. So the COVID virus, the station closed on February 14th, which means that we have no planes coming in or out until October, which means there are no people coming in or out until October. And that also means that we had to get all our food in that we needed for the winter and to store it. But as a result, we are effectively quarantined as a station, just naturally, in business as usual. But down here, we are not. We are in one of the safest places in the world as far as contracting it at the moment.
Yeah, and basically, you're quarantined with the group of people that are there. But if somebody did get some disease that they thought was contagious, you could isolate them in a part of the station as well. Is that correct?
Yes, medical has facility for isolating people, and we also have plenty of spare rooms.
Yeah. So, all right. This one, I don't know the answer, but maybe you and John and you or Jargi know. What's the difference between ice and ice crystals?
So ice and ice crystals, as far as I understand from meteorology, and thankfully Jeff, the meteorologist, isn't near here to yell at me when I'm wrong, are pretty much the same thing. Ice crystals are just very small bits of ice that get blown around on top of the snow. And as they settle, they get compressed and pushed into what we would normally think of as big ice.
Mhm.
I think the difference that we get told is it's not snow that's blowing around outside, it's little chips of ice. And I think the difference there, if I had to guess, it has to do with how it's formed. I think snow tends to be formed in the upper atmosphere, and you actually get snowflakes with patterns.
Mhm.
Whereas ice crystals are kind of ground down ice. They just look like ice out of your freezer that you put through a grinder.
Okay.
They kind of feel, they look the same when you're just looking outside. We call it snow, even though sometimes it's not snow.
Yeah, I think that was when I was there. I tried to go skiing, and it's kind of like skiing on sand, right? It's quite coarse.
Yeah.
Yeah. All right. I don't think anyone here actually did this, but the question is, how did you build the station?
So there is one person on station who was here during the station build, Bill Johnson, our head person, head of preventative maintenance. The station, as far as I understand, was built over several years. It took a long time to get all the material in, and they were in a different station. You may have seen a dome at the South Pole, and that's the station that people lived in before about 2010. It didn't have individual rooms. It didn't have windows. I'm happy to be in this station. One big aspect of this station is it's actually on stilts. So you may have noticed in the background pictures that the station is a little bit off the ice. And that's because the way the ice crystals work here is that things settle into them and then more ice blows in. So the buildings effectively very slowly sink. And so this station was built so that it could be raised as it sunk to make sure that wasn't an issue. The ICL is in a similar position. but it was just built over a long time. I think they had 300 plane flights a year come in to get enough materials down here to build the elevated station.
All right, I'll ask this one to Jargi first, and then to John and Yuya. So Jargi, when you were at the South Pole, did you ever want to leave? I think you're muted, Jargi.
Okay, there we go. Did I ever want to leave? No, I wish I was there now. The South Pole was absolutely amazing. It's so interesting. It's a different world. It feels like life is very different, and it's hard to be away from your family and your friends, but it is such a unique experience, and I loved it. I loved all the different things that came with it, and you're just learning all the time. I think I was learning every single day something new about how the station worked or IceCube. So did I want to leave? No, I didn't. I really love the South Pole. It's my favorite place on the planet.
Cool. How about John and Yuya? Hopefully you don't want to leave.
I don't know. What do you think? No. Yep. No, the only time I was a little, I kind of wanted to be back north was during the holidays, but I'm very happy to be down here, and I don't need to leave anytime soon.
Yeah.
Okay, and then did one of you do a marathon?
Yes.
Yeah.
In early January, the South Pole Station runs a marathon.
Okay.
And there's the sticker we made this year. It's backwards, but it's our 26.2 sticker.
All right.
And yeah, I participated. You took pictures because he's very good at that. I actually walked the whole thing. I managed to walk it in under 7 hours, which for me was an accomplishment.
Very cool.
Yeah, it was fun. It was a fun time. I got a little bit of sunburn. Another problem you might not expect at the South Pole is sunburn. The atmosphere is a bit thinner and the sun reflects off the snow, and the tip of my nose got sunburned.
Cool. All right. We're going to do 3 more quick questions, and then I think we're going to call it a broadcast here. But
Okay.
So first one is, what is the moon like during the South Pole winter?
So the moon is an interesting feature during the South Pole winter, because the moon is actually tilted a little bit in its rotation around the Earth. The moon is up for 2 weeks, and then it goes down for 2 weeks. And it goes through its phases as it does this. One of the people here from NOAA uses the moon to study the density of the atmosphere when it's up.
Yeah.
Pretty cool.
Yeah. Okay. And Judy wants to know, are there any people at the South Pole Station that weren't able to get out before the station was closed in February? That would be a bad thing, right?
No. No, there are not, thankfully. They are very good at getting everybody out by station close. And then we also have a week or so of smaller planes that come through here and use us as refueling. So even if we found a stowaway, I think we'd be able to get them back out if they needed to.
Very good. All right, here's our last question. Well, I guess we'll do two quick questions. I'll do this one. The first one I think is a very quick answer. Is there any dogs at the South Pole?
No, the Antarctic Treaty says no animals down here.
Yeah.
For me, it's one of the worst parts of being down here is no dogs.
Yeah. Okay. And then the last question, I think it's a great one. And then it says, do you monitor the neutrinos 24/7, and do you have to leave the station to do that?
We do monitor the neutrinos 24/7. One of the big draws of IceCube is we are up something like 99.8 to 99.9% of the time. And we can look at the sky in every direction all that time, which means if something happens and someone else sees it, we probably see it too. Now, thankfully for my sanity, I don't have to be there actively monitoring the neutrinos. I can definitely, the computers do it, and they will alert us if something interesting is going on. Or they'll alert us if something broke, which is normally what they're calling us about. They only call when there's a problem.
All right. Okay, and so, and Steven unfortunately came in late, and he wants to know what time is the Zoom meeting next week, and it'll be, I think we're gonna stick at 5, is that right, Madeline and Lindsay?
Yep, that sounds good.
Okay.
5 next
That'll-
week,
will
Central
that
Time.
work for you and John and
Sounds
you?
good to us.
Okay, great. So 5 Central. All right. So fantastic. It was great to see you, Jargi, and John and Yuya. You look better than ever. All right.
Nice to see
Hey.
everyone.
All right.
Thanks, everybody.
Bye,
Good to hear,
everybody.
good to see you. Good to hear you.
Bye.
Bye.